Okay, let's see, we got this in, got this in, everything's visible, okay. Got, talk about linear functions. Graph is a straight line. Slope is defined by a fundamental triangle on that line. That's my definition of the slope. Your book probably has a formula for the definition. We've been over fundamental triangles a number of times. You draw a fundamental triangle, you do run equals, rise equals, and you don't just write a number down here for the run and a number for the rise. You write something minus something, okay? You write coordinate of this point minus a coordinate of this point, and you put those into your calculation so we know, and you know, whether you did it right or not if you review it. If something goes haywire with your problem, then you can look back at that triangle and say, oh, doggone, I used the y coordinate here and the x coordinate there or something. You can see the coordinates that you used. So I emphasize this is how we label a fundamental triangle. This is how we understand slope, not a formula. Now there's a formula and you're welcome to use that too. You should do it both ways. Make sure the formula is consistent with your fundamental triangle. And then you have slope equals rise over run equals, etc. equals, and then you put the number in the box. I put the letter M because that's a letter that we use. Pretty standard letter by a number of authors. Okay, most authors use M for the slope of a straight line. Now, if you happen to know coordinates of the point, then your labeling will be like so. Okay, this is x1, y1, this is x2, y2. Run equals x2 minus x1. And if you know what x1 and x2 are, you can say what they equal, right? And the rise is y2 minus y1. And you fill in the number if you happen to have numbers here. And slope equals rise divided by run equals. And then in the box, what you end up with, should have given myself a little more room there. What you end up with is rise is y2 minus y1, run is x2 minus x1. And that number would go in the rectangle here, next to the slope segment, not over here in your paper, not up here, not on a different sheet of paper, not on your forehead written backwards. So you see it in the mirror every time you look, okay? But here, okay? We got that? Because I see it all over the place. Yeah, you've done it, but you haven't organized it. Now, the way I organize things, I understand you're learning the wrong things as far as organizing. But, you know, and my only excuse is I have to wait and see what you can do before I know what I'm going to do next. And I need to insert things and stuff, and I don't plan it that well to start with. So, so there we have it. Do better than I do. So far, this is organized. And I'm not waiting to see what you know, so the whole thing should be organized. Keep your fingers crossed. Now, okay. Now, equation of linear function. Slope intercept form is y equals mx plus b. And that's the primary form that we're going to use. There are other forms. You're welcome to learn what those forms are. I mean, you could replace m by y2 minus y1 over x2 minus x1 if you want a formula for something that you don't need a formula for, if you know what a fundamental triangle is. Okay, but still, if you're trying to do a lot of problems in a short time, formulas are really handy. But if you're just using formulas blindly, you're not learning much, except how to use the formulas when you have the formula in front of you. What are you going to do on a test when you don't have the formula in front of you? Okay, you need to know what the formulas mean in order to remember them reliably. Now, if you got a photographic memory, you can get away with it. I had a fraternity brother, had a photographic memory, really tough school. He was in chemical engineering or something. He was a smart guy, but he relied on his photographic memory, and eventually his grades started dropping because he wasn't learning how to analyze. And I still ended up with a good point average, and he's a good guy, and I'm sure he had a great career. At least I hope he did. But you know, I observed that kind of firsthand. He was a year or two ahead of me, but you could see it happening. Okay, so there's the slope intercept form. I recommend that you have more pictures in the work you submit, more pictures in the work that you do. Okay, because the pictures show me that you're understanding something that you probably aren't if you don't have the pictures, and that you're reinforcing things that you'd be better off reinforcing. If you're in a big hurry, go ahead and use the formulas and hope you got a photographic memory. But it's not going to be as beneficial to you in the long run. And one thing I say, and you know, this is, I might or might not be wrong about this because who knows how AI is going to unfold. But in dealing in a world of AI, the better you can think, the better you're going to do in most things. And this trains thinking and problem solving. Whereas blind use of formulas trains something that is useful, but not as useful as understanding from basic principles what's going on. Now, there are ways you can do that with formulas too. Okay, but that's kind of deep. This is not as deep as what you have to do to explain why this is a formula in a straight line. Okay. And I could explain that, but you don't want to see it. Now, get myself on track. I think, no, that's the wrong piece of paper. No, okay, that's the back side of the wrong side, but the back side of the wrong side is the right side. So I've got the right paper. I just want to make sure that there are things that I don't forget as I develop these ideas. So I don't think I've forgotten anything so far. Oh yeah, now. You've got to see stuff related to linear functions and transformations. Toolkit linear function. You got a window. You got the red dot. This line's y equals 2. This line's y equals -2. This line is x equals 2. This line is x equals -2. And right there it is. Your toolkit linear function is y equals x. To do it in our standard 4x4 rectangle, you don't even need to subdivide the rectangle. Well, you kind of do because you need the middle. That's the only subdivision you need. You don't need the rest of it. Now you can continue to subdivide it and you find out when x equals 1, y equals 1. Of course, that's what the formula tells you. So there is your toolkit function. Now, I call it the vertical stretch compression factor. It's A. So, well, you do that. Y equals 2A up here. Y equals negative. Picture goes quite low enough. Give me just a second here. And lower the camera. For aesthetic reasons, I don't like to lower it too much, but I went and drew a line down here, so I have to live with it. Okay, and you got x equals -2 and x equals 2. You got your red dot. Which equals, in this case, it's m. So I should call this 2m. Call this -2m. So m is like 2, that's what I was thinking. Then this thing's twice as high as it is wide, and the graph is steeper, right? So slope is going to be m if you do this. Then I'll draw this a little bigger. Y equals mx plus b. Well, you're starting with y equals x. First thing you do is you multiply it by m to get y equals mx. Then all you do okay, again, your y equals 2m, y equals -2m, and of course y equals 0 here. X equals -2, x equals 2. Red dot here. So here's a graph of y equals m times x. And then you add b. What happens when you add b? Well, that moves the whole thing up B units or down, depending whether B is positive or negative. Well, I'll assume a positive B. Let's just say that B is this much. So now we've got the line. Let me do it, contrast a little bit. Y equals B. I overdid it, sorry. So that your window shifts from here to here, and drawn inside that window, here's your graph. There are only two transformations necessary for a linear function. All you have to do is change the slope and then raise it enough or lower it. That should clarify what we mean by the y-intercept. B is y equals B. The graph intercepts the x-axis because, of course, the x-axis is this center line, x equals 0, which I should have labeled over here. And could have labeled over here, but it's already cramped. There's the transformation picture for y equals x, and that should fit in with what you know about transformations in general. For a quadratic function, or an exponential function, or reciprocal function, or reciprocal square, or cube function, you would have a vertical stretch or compression, and then a horizontal shift and a vertical shift. Sometimes for exponential functions, you'll have a horizontal compression. You did an assignment where you dealt with some horizontal compressions, but we haven't really used them and won't until we get to exponential functions because they're pretty redundant. You can do everything with vertical stretches and shifts with the functions other than the exponential. The exponential, sometimes you need a horizontal compression, and you'll find out about that in a few weeks when we start with exponential functions. Okay, so we're not going to worry about that right now. Okay, well, there we are. There's the toolkit function picture. Here's the slope intercept form. And it's that prominent. Now, what else do we need to know? Move right into what we do if we know 2 points. Given 2 points, we find a linear function. Implicitly, that's a linear function that goes through those 2 points, because why else would we talk about 2 points? Defining a linear function. How do you find the linear function? And the slope. M. Plug into y equals n. How do you find the slope? Fundamental triangle and or formula. I recommend both. So you're connecting the fundamental triangle with the formula, and it doesn't take long to do it both ways. Each is a simple picture and a simple calculation, okay? But anyhow, you plug into y equals mx plus b. In other words, now you know m. Plug in the coordinates of one point. Solve for b. Write the formula. Example. Let you pick the number. Somebody pick the x. First person I see with fingers, 2. Somebody else? Got to see some fingers. Okay, I see a 4. That's the first one I saw. You were just a little late. Either that or, my neck is hasn't turned as far as it ought to. Didn't want to hurt myself. Okay, so what was the number? Yeah, 4. Okay, what's your number? Before. No, we don't want to do the same point twice. But we could do, okay, we could do 6. Okay, we'll try another number. No, we don't want 4, because that's the same as this 4, and that would give us a 0 slope. Okay, I got, sorry. Give me some exercise anyway. Okay, 6, 7. That was a 7, wasn't it?
Yes.
Okay, somebody in the hall answered. Okay, points 2, 4, and 6, 7. So we follow the, okay, but 1, 2, 3, 4, 5 steps. Step 1. Slope equals, well, I'm not going to go through the details. I'm going to just sketch a little picture here to indicate it. So it's like we got 2, 4, and we got 6, 7, and we do the fundamental triangle. And we get a slope here. And the slope is going to be 3/2, I think. You can't read any of that. I'm just putting that little scribble there to say you ought to write that out. And I don't want to use up that much room. But m equals 3/2. Your run will be from 2 to 6. Oh, sorry, it's 3/4. Your run will be from 2 to 6. That's your x coordinate. So that's 4. Your rise will be from 4 to 7. So that's 3. Now you want to write everything I said to write when you do a fundamental triangle. Until you're absolutely sure you know what it means, because if you take calculus, it's going to be beneficial to know that. Okay. Helps you sort things out that are otherwise difficult to sort out. And I can testify to that because I'd never seen such a thing when I took calculus. And it caused me to stumble for a week or so until I sorted out what those graphs meant. Okay. M equals 3/4. So there's our slope. And you could also do it by formula. I'm going to say I recommend formula and picture. 2, plug into y equals mx plus b. Well, okay, y equals 3/4 x plus b. That's easy. Once we get m, we replace m by that. That's why I put the underline there. 3, plug in the coordinates of one point. Now we got to vote. Do we use this point or this point? It doesn't make any difference. How many want this one? How many want this one? I think this one has it. Okay. Okay. I'll say choose 0.67, and you get y is 7, so you replace y by 7. You get the 3/4 times x, which is 6, plus b. Or you solve for b. Well, 3/4 of 6 is 4.5. Subtract 4.5 from both sides. You get 7 minus 4.5, which is 2.5. I'm not going to solve that equation for b. You know how to solve equations. And if you don't, do the assignment on solving linear equations. And if you still don't, do that assignment again. Okay? Maybe 2/3 of the number of people here did that. I don't think it's 2/3. I think maybe closer to half. And everybody pretty much got almost everything right, or everything. Okay? Make sure you know how to solve linear equations. So you solve this linear equation for b, and you get 5/2. And then step 5, y equals 5/2 x. Sorry, 3/2 x, 3/4 x plus 5/2. So I've replaced m by the slope from this point to this point. And I've replaced b by what we get here. And that's your slope and your y-intercept. And now we know that the graph would be represented by the y-intercept. Y equals 5/2. And then by a line that runs 4 units and rises 3. So we go over here 4 units, up 3 units. We get another point. There's our line. You'll see all that in open math in detail. This is a summary. This is the bones of the process, and we've been over a lot of it, I think. It just happens coincidentally that we're doing this in my intermediate algebra class. We've done it in the support class. I think I remember doing this here. If I didn't, there it is. Okay. Comes back to being able to do that fundamental triangle, which I think is real important. Fair enough. Not difficult, but do it right. Do it completely and write out everything in detail so that you reinforce it. Okay. Now, next thing. Um, okay, a linear function. Excuse me. Given 1 point on a slope, you'd be able to start with y equals mx plus b. Plug in m. Plug in the coordinates of the given point. Solve for B. Write the formula. And I'm going to say 6. Not sure you know how to graph the thing. Should have said that on the one before. Okay. So example. Point. Okay. What's the x coordinate of the first point? Okay, good. Good. Okay. You tried so hard, I had to give you a chance. Okay, somebody else give me the y coordinate of that point. 8. Whoa, somebody give me a number. 10. Somebody give me another number. Okay, 2. How about a number that doesn't divide 10? 3. Okay. Slope 10, 3. So first one, you write out y equals mx plus b. Second step, you plug in m. You write out y equals 10/3 x plus b. Now, third step, and you could actually combine steps 2 and 3, just take all your information here and plug it in. But I'm doing this in 2 steps just to make sure we're okay. 10/3 x plus b. Now we plug in the coordinates of the given point, which are x equals 4 and y equals 8, and we get 8 equals 10/3 x, 10/3 of x, which is 4, plus b. Or we solve for b. Just to put down dots, you need to know how to solve this equation. Best to multiply both sides by 3. You're going to get 24 equals 40 plus 3b. And so b is negative 16 over 40, over 3. Okay, and I did that quickly in my head. Then you got 40, you got 24, that's going to give you negative 16, 3b. I think that's right. Okay. So you just do the process 5, write the equation. Being literal, I'm using the plus. So I'm doing mx plus b. Of course, plus a negative is the same as subtracting. So y equals 10/3 x minus 16/3. You know, how about our graph? B is the y-intercept. Reason for that? The y-axis is a line where x equals 0, and if x equals 0, y equals negative 16/3. Or if x equals 0, y equals b, right? And remember that the y-intercept occurs when x equals 0. Something you want to remember for the rest of your life, at least the rest of whatever part of your life involves mathematical thinking. Okay. So we need a line y equals -16/3. Now, if you're doing this in open math, then you're gonna have to estimate where -16/3 is, but chances are they're gonna give you a grid and B is gonna be a whole number. So I want you to be able to sketch out your graphs, following the exact steps you see me following. And then, as you learn to follow those steps, think about what they mean and then adapt it to the way you think without prejudicing it for the way you can do it most expediently and get the right answer without thinking. Okay? Make sure you think through every step. It takes a long time to make this stuff really make sense, to get to the point where everything really makes sense, but you want to strive for that. And it's achievable with linear equations and with quadratic equations. It just needs practice and close attention. Okay, so anyhow, you draw the line y equals -16/3 again, because that is B and B is the y-intercept. And that's because when x equals 0, that's what y equals. So we have this point. Now, what do we do from there? Well, the slope is 10/3. That means the run of 3 would correspond to a rise of 10. That makes sense? Well, it would if you'd drawn enough fundamental triangles in your life up to this point. Draw them and label them so you understand that that's the run and that's the rise. So this says you move over 3 and up 10. And you get a point. There's your graph. Now, if you add 10 to -16/3, 10 is 30/3, so you're going to get y equals 14/3, if I did that correctly. And chances are that I did. Okay, so from -16/3 to 14/3, where's your x-axis going to be? Well, 16/3 is pretty close to 14/3. This is 16/3 below the x-axis. This is 14/3 above the x-axis. So the x-axis is going to go, well, y equals 0 is going to go between these, but a little closer to this one. 16 is bigger than 14. So halfway between would be about here. So I'm just going to say, okay, about here. That's the line y equals 0, but of course, the line y equals 0 is the x-axis. Now, -16/3 is -5 1/3. 14/3 is that 3 is not going to be legible no matter what I do. It's 4 2/3. You can say so. You can say here. And that is negative. You know, I got the thing closer to this than this. It should be closer to this than it is to this. So my graph at this point isn't real accurate. Okay, so here is the line. What do you estimate? And the estimate isn't going to be very good based on my graph because I got my x-axis too low. But we're going to make an estimate anyhow. What's the estimate of the x-intercept? with the zero of this function, this point here. What's the x coordinate? Just from the graph, what would you estimate? Okay, I think that I stopped recording after I drew this and labeled the line. Is that correct? Okay, people are nodding yes, either because they want to tell me what I want to believe or what. And y'all are the type I think will tell me. Okay, I think you'd be honest. So anyhow, we've got this graph. We've got the line y equals -16/3, which is -5 2/3. The line y equals 14/3, which is y equals 4 2/3. And we got that, the -5 1/3 or -16/3 from the y-intercept on the equation. And then we move over 3 and up 10, we get another point, which is going to be at the 3 and turns out to be 14/3 or 4 2/3. I've got the x-axis a little bit low. We're estimating the coordinates of the x-intercept. So what are the coordinates of the x-intercept? Well, we try to get the x-coordinate first, and so far, ask people to vote. Is it more than 10 or less than 10? And I got more than 10. Yeah, less than 10. Okay, I got less than 10. And then more greater than 1 or less than 1, I got greater than 1. So it's somewhere between 1 and 10. Well, it's actually somewhere between 1 and 3 because x is 3 here. And x is 0 here, right? So it's between 0 and 3, and 1 would only be, if 3 is this big, 1's only about this big, so it's clearly more than, it looks like it's about halfway, a little more than halfway from 0 to 3. So that would be more than 1, right? Now fudging a little bit because the x-axis is a little low. If the x-axis was a little higher, because it needs to be a little closer to this line than this line, and I got that backwards, that would move this point a little more to the right. So we might estimate x equals 2. Okay. So x equals 2 is a little bit of a stretch for the graph as I've shown it. But all right, x is approximately equal to 2 on this line. So just from the picture, we estimate the x-intercept is at 2, 0. Okay. Now, can we find the x-intercept? It occurs when y equals 0. Why? Because it's on the x-axis. And everywhere on the x-axis, the y value is 0. The x-axis is the line y equals 0. To solve y equals, 0 equals 10/3 x minus 16/3. That'll give you the actual x-intercept. Well, if we do that, I have to write the equation here, and I'm going to write it 10/3 x minus 16/3 equals 0, and multiply both sides by 3. If I put a few dots here, you got to use the distributive law 3 times this and 3 times this. But that's going to give us 10x minus 16 equals 0. X equals 16 over 10, which is 8/5, which is 1.6, which is probably closer to what you would have estimated from this bad picture than x equals 2 is, okay? So even the bad picture, but somehow I can't conceive what the accident would have been. Maybe I'm just looking at yeah, okay. Actually, I positioned this about right. It just looks wrong from this angle. Uh, the actual x-intercept would be at 1.60. Fair enough? Okay, so things are a little bit haywire, disorganized. I'm going to start here. You can have the ax plus by equals c form of the equation. It's easy to find intercepts. I say let x equals 0 and solve for y to get the x-intercept. Because the x-intercept occurs when y equals 0, right? X-intercept is on the x-axis. The x-axis is a line y equals 0. You really want to remember that. It's the second time I think I've said that today, and I probably said it previously, okay? Because you're going to have to do that for more complicated functions all through the course, okay? You've always got to know how to get the y-intercept. You might not know how to solve the equation because sometimes it can be one you just can't solve. But you got to be able to write the equation. And this is the y-intercept, not the x-intercept. If x is 0, you get the y-intercept, as I said, but not as I apparently wrote it. Okay, so if there's a little confusion there, give you a minute to think it through. Okay, an example of that is, let's say we got 4x plus 7y equals 12. Let x equals 0, you plug in 0 for x, you get 4 times 0 plus 7y equals 12, which is just 7y equals 12. Not writing the steps out, you should write the steps out. Because you have to keep reinforcing the steps so you know how to solve linear equations. Sometimes you got to solve them in symbols. So you got to know how to do the steps. Anyhow, you get y equals 12/7. So the y-intercept occurs at the point 0, 12/7. 0 because you assumed that x was 0. And then on the basis of x being 0, you found that y had to be 12/7. So there's a point on your graph, right? And it's on the y-axis. It's the y-intercept. 2 y equals 0, you get 4x plus 7 times 0 equals 12. And 4x got to be hard to read. So 4x equals 12. X equals 3. The x-intercept is at 3, 0. So our payoff is, here's your y-intercept, it's at 0, 12. Here's your x-intercept, it's at 3, 0. Now graph. You just say, okay, your y-intercept is at 12 sevenths, which is 1 5/7. A little closer to 2 than it is to 1. And your x-intercept is at 3, 0. So this is pretty close to 1.5. If you use equal scales, x equals 3 would be here. Now that you've drawn these lines, you're going to be tempted to draw a point here. But these are not the coordinates of any point on the graph. Okay? 3, 12 sevenths is not on the graph. With no point here, but your y-intercept is here and your x-intercept is here. And now you can sketch the graph. If you hit both points and I missed, but you get the idea. Now we could have solved for y. Okay. By adding negative 4x to both sides, you get 7y equals negative 4x plus 12. Dividing both sides by 7. And this ellipsis here and this ellipsis here mean steps you should be filling in detail. We get y equals negative 4 sevenths x plus 12 sevenths. Okay. Now what's the y-intercept? Should be 12 sevenths, right? Well, that's what we got. We solved directly for the y-intercept, so we got the y-intercept right. Okay. What's the slope? It should be negative 4 sevenths. Well, that would be a little more complicated because you'd have to do a fundamental triangle here. You have a run of 3 and a rise of 12 sevenths. Slope is then, turns out to be 12 over 23. The rise will be negative. And 12 over, not 23, 21. 12 over 21 equals 4 sevenths. I just write that as a note. You can go back and do this fundamental triangle, keep your wits about you and do the fractions correctly, which you do need to be able to do because rational functions are coming up before 12th law. You're going to have to do fractions with big old hairy polynomials. Okay? That gets a little bit challenging. If you don't know the rules for fractions, go back and review those sometime. I know you got a lot of extra time, so do it in some of your extra time when you're bored. Okay, yeah, I know. Now, I say no point here. I don't mean that this is pointless. I mean, you don't put a point right here. Okay. You never know how words might be interpreted. Especially when they're garbled words to start with. All right. So that look like something you'd be able to do? Think so, if you've been, you know, if you've been keeping up with things, there should be no big surprise here. But there's a fair amount of work there, 20 some problems. Some of them are pretty easy, pretty quick. If you know what you're doing, most of them are pretty easy, pretty quick. Some of them take a little bit of calculation. Make sure you're writing things out to reinforce. Okay, there's a little more. See how we're doing time-wise. Where's the time? This stupid computer is supposed to show the time. Well, it will if I do this. Okay, I've got 21 minutes. That's about where we ought to be right now, so I think we're good. Another thing that you're going to see, I'm just looking back to make sure there's nothing I neglected to say. I'm sure there is, but nothing in my notes. Wait a minute, now that's going to be. Now I'm going to make it easier. Okay, there's two graphs. There's two functions. We're going to graph those on the same set of coordinate axes. Okay. Nice straight y-axis is a good start. Okay, so let's say first equation, and let's go ahead and make these equations a little more colorful. Let's make the second one orange so we can identify at a glance which equation is which. We're going to label them. Okay, the first one is going to have a y-intercept at 0.5. The second is going to have a y-intercept at 0.12, right? So we're going to want a line up here for y equals 12. Then we're going to want a line for y equals 5. Well, half of 12 is 6. The 6 would be there and 5 would be just a little lower. Maybe y equals 5 here. Now we're going to draw these two graphs. They have different slopes. Matter of fact, one slope is positive, the other slope is negative. If these lines are extended far enough, there's no way they're going to fail to intersect, right? Two straight lines with different slopes have to come together. The only way they don't come together is if they're parallel, have the same slope. So if it's y equals 2x plus 5 and y equals 2x plus 12, they just go all parallel to each other and they'd stay that way. They'd never come together. There'd never be an intersection. And what we're trying to find now is the intersection. So I could put a heading here, intersection. Now later on, we'll intersect a straight line with a parabola. That's really not difficult, but you got to know the quadratic formula. And not sure everybody does at this point. Okay, so y equals 2x plus 5. So let's see. Here's the x-intercept for the first equation, and in orange or whatever that color is, there's the, I said x-intercept, the y-intercept for the first equation, the y-intercept for the second equation. You can tell by the color which is which, or you can tell just by looking at the equation which is which. Now we want to draw graph. We want a slope of 2 on this equation. Now, to get a slope of 2, I could come over 1 unit and up 2. But 1 unit is pretty small on this graph. So I could let's use a run of 5 and a rise of 10. That would get us a slope of 2, wouldn't it? Divide the rise by the run, 10 divided by 5 is 2. And the reason I do that is so I can sketch the run. Let's say x equals 5 occurs here. So I've got this arrow, it's 5 units this way, that's the run. I don't label it necessarily as a fundamental triangle, although it wouldn't be a bad idea to do that. But then we've got to go up 10. So we go up 10, and that takes us from y equals 5 to y equals 15. So we need a line here, y equals 15. So now we've got another point on this graph. So right there is a line that almost hits y-intercept correctly. So it's a halfway reasonable representation of this first line. So we're going to call this y equals 2x plus 5 as best I was able to graph it on a first try. Y equals negative 3x plus 12. Okay, well, there's the y-intercept. The slope has to be negative 3. That looks like I'm subtracting 3 from the slope. A little space in there. So let's use a run of 5. But a rise then would have to be negative 15, because rise over run has to be negative 3. So I choose the run first, and then I multiply it by the slope to get the rise. That's an idea that's pretty obvious if you think it through. So you should think it through. That could be helpful to you later. So here we have this equation. Means we want to go over 5 here. Incidentally, I have 5 here and plus 10 on this triangle. On this triangle, I've got over 5 and down 15. And it gives me a line that looks like this. And lo and behold, the 2 lines cross. And of course, we'd want a line here. If we start at 12 and come down 15, we're at y equals negative 3. So I'm able to sketch these 2 lines. It's a reasonably accurate sketch. What I want is the x and y coordinates where they cross. Well, x is here, 5 is here, x is here. It looks like x is kind of close to 2. Okay? X is approximately 2, and y is approximately, well, it's between 5 and 12. Closer to 5 than it is to 12. That's 7 units. That'd be 3.5 units. Be 3. Now we're just going to say maybe y is approximately 7 or 8. So arbitrarily, I'll do 8 because I don't want to do a fraction. Okay. Don't want to complicate things with like 8 1/3 or something like that. We'll call it 8 or 7 2/3, whatever I think it might be. So X is approximately 2, Y is approximately 8. If this is right, logic here, X of 2 and Y equals 8 to the point 28 is on both lines. So X equals 2X plus 5 should be true if X equals 2, Y equals 8. That means that 8 equals 2 times 2 plus 5. 8 equals 9. Does that equal 9? No. Is it close? Yeah. Yeah. Totally different by a little more than 10%. So it's close, but not exact. Okay. Now also, Y equals negative 3X plus 12. Could be so. Plugging in 8. Oh man, that's going to be a bad 8. Plug in 8 for Y and 2 for X. 8 should equal negative 3 times 2 plus 12. Well, you do the arithmetic, that's going to be negative 6 plus 12. 8 equals 6. And that's sort of close. But not great. So how did I do with my graph? I came kind of close to the intersection point, but if I'd have found it exactly, which is generally impossible from a graph, but if I'd have found the intersection point exactly, I'd have had equal numbers here and equal numbers here. Now let me check the time so I can adjust what I need to. We've got 8 minutes. The way to find the exact solution now, Open Math is going to give you an explanation of this. It's completely consistent with what I'm giving you. I use a little bit of notation to help make it clear what's going on. Okay. And I'll explain the notation as I go. Equation 1 is Y equals 2X. Okay, actually, I'm not going to do elimination. I normally do elimination, and we'll talk about how to do this by elimination. It's going to be, the elimination process is going to be very important later in the course. Right now, you probably do this by substitution. So I say solve one equation for X or Y, and it's your choice, which equation and which variable. I'd rather divide by 2 than by -3 because of negative sign and all that. So I'm going to solve for, well, you plug your solution into the other equation. And solve. And you check your solution in both equations. So, step 1. I said something about dividing by 2 rather than -3. This equation's already solved for Y. Now, if you had an equation like 2x plus 6y equals 19, you'd have to solve for one of the variables, okay? But this one's already solved. So that makes it pretty easy. 2, plug the solution into the other equation and solve. So other equation is y equals -3x plus 12. We get, if we replace y here by the y we have up here, we get 2x plus 5 equals -3x plus 12. And we easily solve that. To make sure we understand what just happened. Y is equal to 2x plus 5. So the equation y equals -3x plus 12, therefore becomes 2x plus 5 equals -3x plus 12. Does that make sense? We're just plugging in, just like we've done for function notation and for a lot of other stuff. Well, then we solve, we're going to get 5x equals 7. And we're going to get x equals 7/5. Third step. Okay, I didn't write these steps out correctly. There are 2 steps here. And I'm not up to the step where I can check the solution. So my third step is to plug the solution into the first equation and solve. So here's my solution for number 2. Y equals 2x plus 5. X is 7/5, so y equals 2 times 7/5 plus 5. Well, that'll be 14/5 plus 15/5 equals 39 over 5. Which is 7.8. What was my estimate? Y should be 8. It says 7.8. So I'm closer than I deserve to be. Now, I wasn't all that close necessarily with my X. X is 7/5, which is 1.4. How does that compare with my estimate? Well, my estimate was X equals 2. Now, if I look at this, it's pretty clear that this might be a little bit less than 2. If 5 is here, that might be a little less than 2, but it looks pretty close to 2. So my graph was a little bit flawed there. Lines weren't completely straight. Something is haywire. So my estimate wasn't bad, but it wasn't great. I only missed the Y coordinate by like 6%. Okay. I missed the X coordinate by about 30%. But it's tough to do this accurately with a hand sketch graph. Still beneficial to you to do hand sketch graphs and do estimates that aren't exact, because when open math gives you these things, the lines are always going to cross at grid points. Almost always. Okay. And that's a little bit, you get the procedure, but you understand it better if you sketch it out first and have some errors in your estimates. Then you get to see something about the estimation process and evaluating errors. Okay, so how did we do time-wise? I'm 1 minute off, so there's a, what's that, a 4% error?